Okay, so USGS has put out this new schematic of the water cycle by including some of the human activities into the water cycle. We have seen the water cycle in several different places now in several different courses. I'm going to include this here since it's relevant as human impacts on the water cycle as well as new finding summarizing the impacts of humans on the water cycle. I'll show the schematic in a minute, but the water cycle describes where water is on Earth and how it moves. Water is stored in the atmosphere, on the land surface, and below the ground. It can be a liquid, a solid, or a gas. We all know that. Liquid water can be fresh, saline, or salty, and a mix or brackish. Water moves between the places it is stored. Water moves at large scales and at very small scales. Water moves naturally and because of human actions. Human water use affects where water is stored, how it moves, and how clean it is. So the water movement by humans is not only as in water form, but also we grow grains, fruits, vegetables, and transport them. So we move some water with that, and some people look at that as a virtual hydrologic cycle, and people worry about how much water, for example, is being used in a place like India with its water issues and then exported as water in the form of grains, vegetables, fish, or whatever else from aquaculture to the places where water may be abundant. So we keep doing these things. So to define a few things, pools of water or reservoirs. So typically, whether it comes to carbon or water or any other greenhouse gas, we think of reservoir size and the fluxes between the different pools. So pools store water. In this case, 96% of all the water is stored in oceans and is saline. We've seen this in our basic oceanography course. On land, saline water is stored in saline lakes. Fresh water is stored in liquid form in freshwater lakes, artificial reservoirs, rivers, and wetlands. Water is stored in solid frozen form in ice sheets and glaciers and in snowpack at high elevations or near the Earth's poles. Water vapor is a gas and is stored as atmospheric moisture over the ocean and land. In the soil, frozen water is stored as permafrost, and liquid water is stored as soil moisture. Deeper below the ground, liquid water is stored as groundwater in aquifers within cracks and pores in the rock. Okay, nothing new there, but just defining these things. Fluxes move water between the pools. As it moves, water can change form between liquid, solid, and gas. Circulation mixes water in the oceans, transports water vapor in the atmosphere. Water moves between the atmosphere and the surface through evaporation, evapotranspiration, which is mediated by vegetation, and precipitation, which falls back in either liquid form or snow or hail and so on. Water moves across the surface through snowmelt, runoff, and stream flow. Water moves into the ground through infiltration and groundwater storage, of course. Underground, groundwater flows within aquifers. It can return to the surface through natural groundwater discharge into the rivers, the ocean, and from springs. And of course, humans are mining groundwater for various uses, domestic, agriculture, industrial, and so on. Okay, so we alter the water cycle. We redirect rivers. We build dams. We link rivers. We build dams to store water. We drain water from the wetlands for development. We use water from rivers, lakes, reservoirs, and groundwater aquifers. We use that water to supply our homes and communities. We use it for agricultural irrigation and grazing livestock. We use it in industrial activities like thermoelectric power generation, mining, and aquaculture. The amount of water that is available depends on how much water is in each pool. So that's the water quantity. it also depends on when and how fast water moves, so the water timing is important, how much water we use, the extraction part, and how clean the water is in terms of water quality, right? We affect water quality also in agricultural and urban areas. Irrigation and precipitation wash fertilizers and pesticides into rivers and groundwater. Power plants and factories return heated and contaminated water to rivers. Runoff carries chemicals, sediment, and sewage into rivers and lakes. Downstream from these sources, contaminated water can cause harmful algal blooms, spread diseases, and harm habitats. Harmful algal blooms are basically algae that grow in the water bodies that are harmful to us or to fish. Climate change is affecting the water cycle, of course. We talk about accelerating hydrologic cycle, extreme events, and of course fueling cyclones, hurricanes, and so on. It's affecting water quality, quantity, timing, and use. It's causing ocean acidification, sea level rise, and more extreme weather. By understanding these impacts, we can work towards using water sustainably. Okay, so here is the big picture. You can see here the general overview of how the water moves from the ocean onto land, back on the land itself as evaporation, precipitation, snow, building of glaciers, and then melting, river runoffs back into the ocean, infiltration into the groundwater and back into the ocean, and so on. And you can see the details here: atmospheric moisture over the ocean, and transport of moisture from ocean to land. And of course there is precipitation over the ocean and precipitation over land, and ocean of course evaporates a lot of water. Even though most of it falls back, what gets transported to land is very critical as well. There is ocean circulation, which moves temperatures, heat, water, and there is the ocean mixed zone near the surface where heating, cooling, and winds generate turbulence, and then there is the ocean deep water zone. And the ocean is of course getting infiltration of groundwater, which you can see collects from various places, from permafrost, groundwater recharge processes, agricultural water use, or mining of groundwater aquifers, and there is soil moisture and so on. And groundwater discharge into the ocean happens, of course, and as the groundwater is mined and pressure gradients are changed, intrusion of salty water into the aquifers is also a serious issue now. Precipitation over land, of course, goes into runoff, domestic water use, wetlands which are brackish, lakes which are fresh, stream flows into closed basins like lakes can be fresh or salty, so fresh and saline. And of course there is overall evapotranspiration mediated by vegetation, so there is atmospheric moisture over land as well. And of course we are building and melting ice sheets and glaciers, snowpacks. Humans are impacting snowfall rates, seasonality, and of course snowpacks themselves, and precipitation over land also is going into snowmelt, into reservoirs, into groundwater recharge, and there is evaporation from human use of land with agricultural water use. So you have irrigation, which creates excess evaporation, and then you have evapotranspiration, which is a measure of course crop yields in many ways. And grazing water use, so meat production is big business, so cattle, sheep, and so on. Also all the other poultry businesses use water as well. So we are also introducing water quality issues through municipal water use, industrial water use, and of course affecting stream flows into the ocean as well. So pools and fluxes, again, on Earth water can be fresh, saline, or mix of both. Pools are places where water is stored like the ocean. Fluxes are all the ways in in the ways that water moves between pools, such as evaporation, precipitation, discharge, recharge, or human use. Okay, so just a recasting of what we know, but adding all these details of human activities and providing the background on how we are affecting the water cycle, in addition to, of course, warming of the ocean, increasing evaporation, warmer atmosphere, more moist atmosphere, because warmer atmosphere holds more moisture, and that results in changes in precipitation. But this is complicated by the fact that rainfall falls as more extremes, so higher intensity, duration, intensity, and frequency of these events are also changing. For example, in a place like India, where the monsoon onset and withdrawal happens, length of the rainy season can change, number of rainy days can change, intensity of the rain, active break periods, and so on can change, which are all part of the water cycle, of course, and human impact is manifest in all of them as well. Okay, I just wanted to include it because it's been put out and got some publicity, and it's nice and useful in some of our basic courses. So I'm going to put it in a couple of places in oceanography and so on. Okay.